In this video, we're going to talk about class destructors just a little bit more. I already introduced destructors to you in the previous video on managing memory with new and delete. But I just want to talk about them a little more specifically here and kind of reinforce some of those concepts. So a destructor is a special member function that gets called when an object is deallocated. And here I'm showing you an example of the rectangle object's destructor. We know it's the destructor because it has the little tilde on the front. It takes no arguments. And when the rectangle object gets destroyed, I'm just printing a string, I've just been destroyed. And obviously that's kind of silly. You never would really want to do this on most objects, print a message when it's destroyed, but it's just illustrating that I can take some action when the object is destroyed. The destructor always is like a constructor. It always has the same name as the containing class. So it has the name rectangle, it has a tilde at the front, and it takes no arguments. That's the pattern we always have to follow for a destructor. Also, there can only be one destructor in a class. So the compiler always knows exactly which one to pick because there's only one, and it should run that one when it's destroyed. If a class has no destructor, then, or if we don't implement a destructor for a class, then basically nothing extra happens when an object is deallocated. There are several purposes for which you might want a class destructor. Some objects need a cleanup action when they're being deleted. A very common example is when you need to free a member object that was allocated by the class. We need to do this in order to maintain abstraction, right? Abstraction is this idea of hiding details about how a class works. So if when I construct an object to allocate something, then I allocate something in memory using new, then when the object gets destroyed, it should it should itself delete the things it previously created. And if I don't, then I'm actually breaking my abstraction because those objects are going to stick around in memory for a long time and possibly cause problems and memory leaks that would then become visible to a user of the class. And we wouldn't want that to happen. Another thing you could do is maybe notify another object that it's being deleted. Like, for example, if you wanted to implement a subscribe and unsubscribe service, then when an object is born and starts subscribing to something, you might register it with the service, and then when it gets deleted, you want to unsubscribe it from the service. And then another example might be closing a file or relinquishing a shared resource that it's been using to make sure that once that object is destroyed, that that resource becomes available for some other object to use. Here's an example of freeing memory that's hidden behind an abstraction. Let's say that I have this class called Free Willy, and sorry, I just couldn't resist the reference to the 90s movie. That's probably before you guys were born, but anyway. So inside this class Free Willy, there's an array called Willy that we allocate, and when we construct this object, we allocate an array of 100 integers, and then when this object is destructed or deallocated, what we need to do is free that array because since it's private, there's no one else that could free it for us. It has to be freed by the object itself in its destructor. And so whenever this object gets deleted or deallocated, then this destructor will additionally run and delete this array for us. Okay, here's an example of that subscribe, unsubscribe. Let's imagine we have some class called subscriber, and then there's some other class, I won't describe how it works here, called service. And when we create this subscriber object, it's going to receive a service as an argument to its constructor, and it will register itself with the service. So maybe it'll call some function called subscribe, and it will provide the service with its address so that the service knows that this object is a subscriber. And then when the subscriber object is deallocated, then it will tell the service that it's no longer interested in subscribing and will unsubscribe. This has a nice, symmetry, right? That when the object is created, it subscribes. When the object is destroyed, it unsubscribes. You could imagine other ways of setting something like this up, but this would be kind of a minimal way you could go about it. Okay, and then another common example of a use for a destructor is closing a file. So let's say that I have a class called a logger class, and this logger is going to make it easy for me to dump messages to a file while a program is running. And so embedded inside my logger, I have a private member variable that lets me send strings to a file. In C++, the object you would typically use to do this is called an OF stream. So this stream is like an output stream, like we've talked about before. It's like cout, but the F tells us that it's for operating on files. And when we construct this object, we're going to give it a string, and then we'll initialize this this file stream object using a name and using this this value that tells the stream that it's going to be an output stream, and this will open the file for us. And then there's a member function called log that we can pass a string to, and it will write that message string out to our file. And then when the logger is destroyed, we close the file to ensure that everything we've written to it gets properly written into the file in storage. Here's an example of how we could use the logger. We could just instantiate an object instance called L of type logger. And then we could call the log member function to write hi to the file. And then we could write done to the file. And then when this function ends, it'll destroy the logger object and trigger the destructor to be called, which will close the file and ensure that the contents of the file are safe. Okay, so when should we call a destructor member function? Well, we should never call a destructor explicitly. You're never going to write out code with a tilde in front of it. Never do that. Instead, let the compiler always do it for you. It either happens as part of a delete call, or it happens implicitly for local and global objects when they go out of scope. For example, if I have a heap object, then add a delete statement that will delete the object. Of course, it is the programmer's responsibility to call delete eventually on any object in the heap. So if we use delete, that's going to trigger the destructor. But if I have a local object declared in a function, then it gets automatically destructed just before the function returns, and the compiler will insert that call to the destructor for us. We don't need to do it. Or if we have a global object, it gets automatically destructed just before the program ends. Again, the compiler inserts that call at the right place to ensure that global object is destructed. We don't need to do that ourselves. So we're never actually going to stick a destructor call into our code, but we still have to implement that special member function so that we do the right thing when the object gets deallocated. Okay, so in summary, class destructors perform cleanup actions when an object is deallocated. There can only be one destructor in a class. It must have the same name as the class and begin with tilde, and it may not have arguments. We use destructors for a lot of different things, but here are some examples. We could free a member object that was previously allocated in a constructor or another member function. We can notify another object that, that we've just deleted the object. Or we could use to close a file or relinquish a resource it's been using so that other objects would then be able to use it. We never call the destructor explicitly, instead the compiler does it for us as part of other memory management actions.